Okay, so next here we're going to have a look at the mandatory experiment. Now it's important to note that this mandatory experiment is primarily an ordinary level experiment. Very rarely comes up on the higher level, but obviously still needs to be done. So what you're asked here is to find out the amount of suspended solids, and suspended solids are small particles that are present in the water. Then we have to measure the total of dissolved solids, and dissolved solids are something that is dissolved in the water itself. So we have to evaporate out the water in order to be able to work out how much of that we have. And finally then our pH of the water sample. So we're going to look at A in more detail. So what you have here, there's probably 4 bullet points to each. You have to just learn these 4 bullet points if you're asked for the determination of either one of these. So suspended solids by filtration. Firstly, you have to filter, and filter known volume has to be present, and through weighed filter paper has to be present as well. So you find the mass of your filter paper, you then filter that known volume through the weighed filter paper. You allow the filter paper to dry, you reweigh, and you find the increase that is now on your filter paper. And how do you do that? Basically, you're going to take away your final mass minus your initial mass, and that gives you your mass of your residue. Those residue is your suspended solids. So we find the mass, and then once we found the mass, we find it in grams per litre, and then we find it in ppm or milligrams per litre. If we have 500 centimetres cubed, we'd have to multiply the mass here of my suspended solids by 2 to convert it into grams per litre. And then I have to multiply it by 1,000 to convert it into milligrams per litre or ppm. I'll be doing a sample calculation of those in the next video. Total dissolved solids by evaporation is very similar, where again we evaporate a known volume to dryness, and again we have to have a known volume because we need to know that in order to work out how much we'll have in a litre of solution. Again, my container has to be weighed, okay, so for example your beaker or your clock glass. You cool, and it's very important you cool, so that has to be present. Remember, solids, liquids and gases all expand when heated, so we have to allow it to cool in order to get its mass. We reweigh and we find the increase, okay? So the final minus the initial mass of the beaker is going to give me my mass of my dissolved solids. This time we'll say we've only evaporated 100 centimetres cubed. So I have to convert that into litres, so I have to multiply it by 10. And finally then I have to multiply it by 1,000 to get to milligrams per litre or ppm. Again, I'll be working through a sample calculation for that in a minute. So those 4 bullet points have to be present. The final part then is our pH of water sample. And the more accurate way to do this is to use a pH meter. So in order to do that, using a buffer solution, so say we have pH buffer 10, I calibrate my pH meter so that it reads 10. And then I'd place my electrode of the meter into a sample and I just read the value that's on that. pH meters are very expensive, so we don't come across them in a lab. So the way we do this is you either add a few drops of universal indicator or add universal indicator paper, and then you compare the coloured solution to the coloured chart. It doesn't actually matter there which one you use or which one you write up. So long as you have the correct procedure, you will get your marks there for pH of a water sample.